So welcome to the next lecture. In this lecture, we are going to study about the carrier recovery and clock recovery from the received signal. That is the received transmitted signal. Okay. So either BPSK, that is the digital carrier received signals. Okay. So now out of this one, why it is required carrier recovery or clock recovery? As we know that one, the carrier frequency and phase and also the local oscillator, that is received signal carrier frequency, must be synchronized. Similarly, clock frequency also must be synchronized. Otherwise, you cannot receive exactly the message signal at the receiver side. So, what is the carrier recovery? So, this is what we are defining. Carrier recovery is the process of extracting a phase coherent reference carrier from the received signal. So, it is the phase coherent reference. So, sometimes this also called as a phase referencing also. Now, let us study about the one type of the carrier recovery technique we are calling as a squaring loop carrier recovery circuit. So, let us take an example for the BPSK receiver. So, the block diagram of the squaring loop carrier recovery is like this. So, there are four blocks in this recovery. The first one is the band pass filter, second is the squarer, third one is the PLL, what we are referring as a phase lock loop, and then a frequency divider network. So, the input BPSK signal is passing through a band pass filter to avoid the unwanted signal. So, it is only passing the band of the frequency of the BPSK signal. After that, we are squaring. So, the squarer of the BPSK signal here, and then we are applying to the phase lock loop. So, this phase lock loop provides the VCO output. This VCO stands for the voltage control oscillator. This oscillator frequency and phase must be synchronized with the BPSK signal. So, then these VCO output we are applying to the frequency divider network. So, why it is required, all the things we are going to study the next further. Now, let us see the BPSK signal. We know that mathematically it is represented by this one. So, ST, S1T and S2T. S1 stands for the, when the symbol is 1, this is the signal is transmitting. When symbol is 0, this is the signal is transmitting. It is nothing but opposite to the magnitude, it is nothing but a 180 degrees phase shift, as already we know. So, for simplicity, we assume that one, the 2 EB by 1, so that it becomes simply, it is a positive for symbol 1 and a negative for symbol 0. Okay. So, this is what the first step. The first step we are passing it to a, you assume that one is a band pass filter, so that again the same signal is we are going to be received. Then the squaring of the process here, squaring, by squaring what is happening? So, S1T or S2T, if you take square of the S1T or S2T, simply cos square or minus cos square. It is the minus of cos square, both are same, cos square. So, both will become a cos square 2 pi FCT. So, that the cos square 2 pi FCT can be represented in terms of half of 1 plus cos 2 omega CT. So, 2 times the message signal, already we know that one based on the trigonometrical identity. So, this is expansion, we are going to get half plus 1 by 2 cos 2 omega CT. So, this is the a DC component will be filtered out, we are taking as the half of cos 2 omega CT. So, we know that one is the 2 pi FCT or omega CT, but here the output here is the 2 times the original carrier frequency. Okay, so that since it is a 2 times, we are applying for the frequency divided network. So, that by using the frequency divided network by 2 times, so we apply the carrier frequency. So, this is the process of the recovery of the carrier frequency from the received BPSK signal. So, it is another circuit what we are referring as a Costas loop carrier recovery. So, previously what we have studied a squaring loop technique, this is another technique we are using as a Costas loop carrier recovery technique. So, what is the Costas loop carrier recovery technique is like this. So, it is the BPSK signal we are giving as input to this one, and then it is a carrier signal here we are representing as a cos and minus 90 degrees phase shift we are getting. So, sine and cos, again we are multiplying with this these two signals both sides and the low pass filtered. So, we are adding here, again we are applying to the VCO. So, voltage control oscillator. So, voltage control oscillator, this phase and frequency components of the input BPSK will be controlled by voltage control oscillator, so that we output will be getting as exactly the frequency phase of the BPSK signal. This is another type of the signal circuit. So this is a quiz test. What do you understand by the term carrier recovery in the digital communication receivers? So the answer is carrier recovery is the process of extracting a phase coherent reference carrier from the received signal. The next is the clock recovery. Clock recovery, as with any digital system, the digital radio requires the timing or clock synchronization between the transmit and the received signal circuitry. Because of this, it is necessary to regenerate clocks at the receive side that are synchronous with those at the transmitter. A simplified circuit already might have studied in the digital circuits. Simply we have to suppose we are receiving a signal with a half bit delay, so that we are applying these two to a XOR gate. So with that XOR gate, automatically we are going to recover the clock frequency from the received signal. Say for example, so this is the data we are receiving, okay. So original data, it is delayed data we have received this one. So this delayed we are taking as a half bit delay. So by taking the XOR gate, automatically we are going to get the clock recovery, as we have already studied in the basic digital circuits. So with this one, end of this one, and then there is a quiz test, why clock recovery is needed in the digital receivers. So the answer is this one. So with this one, end of the digital carrier modulation techniques.